Climate scientists are gaining an understanding of the past and are projecting what the future climate might be like through the use of climate models. But what are climate models and how do they work? Join us for the next few minutes to learn about these sophisticated tools and their application in helping us understand the recent past history of the climate. A climate model is like a virtual Earth. It's designed to mimic the real world so that scientists can project future climate scenarios. Climate models are composed of computerized representations of components that represent the atmosphere, ocean, sea ice, land surface, and other processes. Climate models do not rely on guesswork. They describe the climate system with mathematical equations based on laws of physics and solved with sophisticated computers. To give you an idea, what is shown here is the system of equations that describes the basic properties of the atmosphere, its temperature, density, velocity of the air, and so on. This is actually a relatively simple example that nevertheless can only be solved through the use of sophisticated computers. To represent the behavior and effects of clouds, as well as the movement of the air, its temperature, density, and moisture content, the basic atmospheric properties are evaluated at a grid work of points laid over the surface of the Earth that extends vertically into the atmosphere. The tower in the diagram gives an indication of what the grid looks like. We can solve the system of equations for these properties at every one of these grid points. This involves millions and millions of calculations. Because of computing and other limitations, some processes in climate models, such as those representing clouds, are described only approximately, using representations called parameterizations. These parameterizations are an important source of uncertainty in climate simulations. Only a small number of climate research groups have the capability to develop and run the complex, comprehensive models that are required to understand the past and future evolution of the climate. The projections they generate help inform the world's policymakers about human-induced changes in climate. Their results have been impressive. The objective of climate modeling is fundamentally different from that of weather forecasting. Climate modeling deals with climate, while weather forecasting deals with weather. Weather and climate are different. What we all know and often complain about is that weather is always changing, sometimes on an hourly basis. Climate is a statistical description of the state and variability of a system. Weather forecasting seeks to forecast the weather for a short period ahead, while climate modeling seeks to project the statistics of weather for long periods of time, often for periods long in the future. A climate model can tell you it will be cold in winter, but it can't tell you what the temperature will be on a specific day. That's weather forecasting. Let's step inside a climate model to experience a simulation of the seasonal evolution of surface temperature. We are looking at the average temperature for each month as simulated for a recent 20-year period. At high latitudes, cool temperatures, indicated by shades of blue, occur in wintertime. Warm temperatures, indicated by shades of red, occur in summertime at high latitudes. You have to remember that what the climate model is showing are average temperatures, day and night, for a given month. If you think about your own experience and ask whether or not the model is simulating temperatures similar to what you would actually feel in summer and winter, you'd find that it's quite accurate. Ocean temperatures change throughout the year as well, but at a different rate and amount than temperatures over land areas. Over land, temperatures vary a great deal between warmest and coolest times of the year, whereas temperatures over oceans are much more moderated and change more slowly. At very high latitudes, in the Arctic for example, the change in temperature is much more extreme, with many areas descending well below -30 during the coldest times of the year. Models are used to understand the causes of past climate change and to project future climate change. Since the causes of observed changes are not always readily apparent, climatologists use a process called attribution to determine the likely causes of observed climate change. In this process, they first use their climate models to estimate how outside influences such as greenhouse gas increases since the Industrial Revolution should have caused the climate to change. They then use statistical tools to look for those expected patterns of change in climate observations gathered over the past 50 to 100 years or longer. These expected patterns, which are distinct from natural internal patterns of variability, are called fingerprints. Attribution, then, is the combined result of detecting the fingerprint of an outside influence in observations, and then carefully demonstrating that other possible causes of observed changes provide less convincing explanations. So what kinds of outside influences on the climate system are we thinking about? Greenhouse gases, aerosols, solar output, and changes in volcanic activity, to name a few. Now a look at how climate models can reproduce observed changes at the global, continental, and regional levels. The black line on both of these charts indicates observed global mean surface temperature variations. We can see that observed temperatures have risen approximately 3/4 of a degree since the beginning of the 20th century. The two colored lines, orange on the upper chart and blue on the bottom, show the results from two different groups of models running multiple climate change simulations. Both included the influences of solar and volcanic activity. However, the models represented by the orange line also included human influences, such as greenhouse gases and aerosols in their calculations, and as a result, reproduced the observed changes in global mean temperature quite well. You can see that without including human influences, the models represented by the blue line could not reproduce results similar to global observations during the second half of the 20th century. These external factors, including human-induced ones such as greenhouse gases and aerosols, and natural ones like solar and volcanic, are often called forcing agents because they alter the flows of energy into and out of climate systems. The forcing is said to be external because it originates from events such as a change in the brightness of the sun that occur outside the climate system. Now let's look at what happens at a continental level. The black line in the diagram of North America indicates observed decade-by-decade changes in continental mean temperatures. Notice the 1930s, the Dust Bowl and Depression era, which was warm. The last part of the 20th century was also very warm. The blue band shows the range of average temperature changes simulated by climate models, taking into account only natural forcing agents. The pink band shows the simulated temperature changes that include both natural and human forcing agents. For North America and every other continent, we can see that the decade-by-decade changes in observed temperatures fall within the pink band throughout the 20th century, but that they rise above the blue band in the last few decades. This indicates again that simulations which include human influences provide a better explanation for observed changes than those which don't. Therefore, we can conclude that observed changes in the climate system on a continental level cannot be reproduced without including human influences. What happens at even smaller scales? Again, in each region, we see that the models that include human influences, such as greenhouse gases and aerosols, provide a better representation of observed temperature changes. However, it is more difficult to attribute cause to effect at a regional level because the effects of weather and natural climate variations are more apparent at these scales. We have seen that climate models are a reliable means to assist scientists in understanding the causes of past climate change and to project future climate change. Hopefully you now have a better sense of what these complex models can do and the important role they play in understanding our past and future climate on Earth.